Yeah, good morning students. So we are continuing our chapter on trigonometric ratios and identities, and today we are going to discuss about graphs and other useful data of trigonometric functions. So we are going to see how the graphs of trigonometric functions are going to look, and we are going to discuss their domain and range, and we are going to discuss their periodicity. Yeah. Okay, so let's go for the sine curve. If we see sine curve, the sine curve we all know it, actually the famous curve, how it looks is like this. So we all know that actually generally the waves of the river, or if at all they want to show the heartbeat of the patient, or so they show it something like this. So we might have seen it many times, but let's see how it looks exactly. This is y-axis, and this is going to be x-axis minus x-axis, y-axis and minus y-axis. So the sine curve is going to extend till infinity like that, and continuation here. Yeah, so this is going to be 0, x equal to 0, and sine, if you see the graph, is just running between y is equal to minus 1 and y is equal to 1. This should be very clear point. Actually it's running between minus 1 to 1, and now when it will become 1, this value is pi by 2 degrees, that is nothing but 90, and again this becomes 0 at a pi, and again it becomes minus 1 at 3 pi by 2, again it becomes 0, 2 pi. So from here, if you see carefully, the graph from 0 to 2 pi is just copied and pasted, copied and pasted, copied and pasted. So this is called periodicity. The graph is repeating after every 2 pi interval of time. I think it should be very clear. So now let us see about the domain and range. So the domain means what values of x you can give inside the sin x function. What values of x we can give? Yeah, I think the graph is not breaking anywhere. We can give all the real numbers inside the sin x function. And next, coming to range, between what y values the graph is always running. Yes, we can easily understand that closed bracket minus 1 to 1, because minus 1 and 1 are also included. Sin 91, sin 270 is minus 1. Okay, now we will talk about periodicity. Yeah, so if we talk about periodicity, the graph is just copying and getting pasted for 0 to 2 pi. So we can say that it is a periodic function with period 2 pi, because with this 2 pi period, actually if you see this much interval, the graph is getting pasted anywhere. So it's like going to repeat after every 2 pi interval. Means imagine if sin 37 is some value, sin 2 pi plus 37, 360 plus 7, 397 is also same value. This is called periodicity. Okay, so fine, this is about the sine curve. Okay, now let's go for cos curve. So cos curve will be little lagging than the sine curve. Sine curve goes ahead, cos curve little lags. So how the graph starts? My little graph is little compressed kind of thing, it will not be like that. 0, and this is pi by 2. This is pi, and this is going to be 3 pi by 2, and this is going to be 2 pi. If you see carefully, yeah, the graph, okay, the same values will be coming over here. Minus pi by 2, minus pi, and minus 3 pi by 2, yeah, and minus 2 pi. And if you see, again the graph is running from minus 1 to 1. I think this should be a very clear point. Again the graph is running from minus 1 to 1 only, so range is going to become minus 1 to 1. If you see domain also, there is nowhere the graph is getting break, so we can say that all the real numbers is the domain for the cosine graph. Again periodicity, yeah, I think if you see carefully, 0 to 2 pi, whatever you take, if you copy paste again, you are getting the same, or from here to here the graph is again repeating. So simply we can write it as domain is equal to all real numbers, range is equal to again minus 1 to 1, and periodicity, or you can say period, is equal to again 2 pi. I think this should be very, very clear for you. This is about the cosine graph. So I'm erasing this. Okay, so now going ahead with the other one, that is I'm erasing to the shading of the graphs. Tan graph. So this is something little different. So this is positive x-axis, this is negative x-axis, this is going to be positive y-axis, this is going to be negative y-axis. Now I wanted to draw some dotted lines at pi by 2, 3 pi by 2, and here minus pi by 2, minus 3 pi by 2. Why? How do I say you? Tan 90 is going to be infinity, right? Tan minus 90 is also going to be minus infinity, and tan 0 is 0, tan pi is 0. So let's put a value here. This is pi, this is pi by 2, and this is going to be 3 pi by 2, and this is 0, this is minus pi by 2, this is minus pi, and this is minus 3 pi by 2. It should be very, very clear now. So the graph at minus pi by 2, it is going to be minus infinity. So graph starts here, and at 0 it is 0, and at plus pi by 2 it is plus infinity. Again same thing is going to happen like this. Yeah, if you say carefully, this is the graph of tan, and I think you can understand minus pi by 2 what graph is there. It is going to repeat even from pi by 2 to 3 pi by 2, or minus 3 pi by 2 to pi by 2. So that means we can say that period of the graph is pi. And if you see carefully, there is a breakage for the graph at pi by 2, at 3 pi by 2, minus pi by 2, minus 3 by 2. All the odd multiples of 90 degrees, the graph is not existing. So in the range actually you will not have an odd multiples of 90. So you can write that not in the range, domain. So domain is equal to all real numbers minus set of 2n plus 1 into pi by 2, where n belongs to integers. So this is going to become the domain, because all the odd multiples we have to remove. And the range is going to become, I think from everywhere it is there, actually range will be real numbers. There is no breakage in the y-axis, and period is going to become just pi. So this is about the tan graph. It should be very, very clear actually. There is no much confusion about that. So now let's see about the remaining graphs, that is secant x, cosecant x, and cot x are remaining. Okay. Okay, so let's go to the graph of cosecant x, because cosecant x is nothing but the reverse of sin x. So how it's going to behave? Again, x-axis minus x-axis y-axis minus y-axis. See cosecant, see sine 0 is 0, then cosecant does not exist. Sine 180 is 0, then also cosecant does not exist. Sine 360 is 0, then also the cosecant is not going to exist. So we have to be little careful. That is sine 0, sine 180, 360 minus 180 minus 360, again it is minus pi, this is going to be 2 pi, and this is going to be minus 2 pi. So if you see carefully, cosine 0 is 0, so at that point also it does not exist, and 0 to pi sine is always positive, and the graph from 0 to pi is going to be like this. And what is this value, sir? This value is going to become minus 1, this value is going to become 1, and again the graph very simple to understand. So all these values are 1, and this is going to be minus 1. So the graph is going to repeat. If you see carefully, every 2 pi interval the graph is going to repeat. So again here also we can write the domain as, I think in domain actually the multiples of pi does not come, so we can write all the real numbers minus set n pi where n belongs to any integer, and this is now range is going to become set r but minus open bracket minus 1 to 1, because there are minus 1 and 1 are included in the range, that's why I have written open bracket. And if we come to period is again 2 pi here. So this is about the cosecant x. I think it should be very clear actually. Fine, then I am erasing this. Yeah, this is making some dust out of it actually. Okay students, fine. So let us discuss about now secant x graph. So secant x graph is going to be, okay, sorry for drawing like this, it should be in the middle. X-axis, so the secant x graph is going to be again same. It is cos is going to become 0 at 90 degrees, so secant is not going to exist. So do one thing, this is pi by 2 and this is minus pi by 2 and again plus pi. This is going to be 3 pi by 2 and this is going to be minus 3 pi by 2. It's not going to exist in that intervals. So if you see carefully, at 0 cos is 1, so cos is positive, and so the graph is going to be like this, and this value is again plus 1, and here the graph is going to be like this, and this value is minus 1, and so the graph is going to repeat again here. Yeah, here the graph is going to be like this. So again here also domain is going to become set real numbers minus 2n plus 1 into pi by 2 where n belongs to any integer, and the range is going to become set real numbers open bracket minus 1 to 1, and the period is going to become again 2 pi. I think this should be very clear about the secant x graph. Yeah, so fine. Okay friends, so let's discuss about now cot x graph. See, cot x is nothing but reverse of tan x. So cot x is equal to 1 by tan x. So let's see how it's going to happen. So that means one easy clue we can understand that cot x is not going to exist, where tan x becomes 0. Tan x becomes 0 at 0, at pi, at 2 pi. Similarly here also, negative side minus pi, minus 2 pi. So if you see carefully, at 0 it does not exist, at pi also, yeah, tan pi is 0, it does not exist, yeah, at pi by 2 let us have some mark, and 3 pi by 2, and minus pi by 2, and minus 3 pi by 2. If you see carefully, tan pi by 2 is, so tan pi by 2 is infinity, so cot is going to become 0, that is very clear. And tan pi, we can call it as a negative, tan pi is negative 0 kind of thing. So because actually if you see carefully, tan pi is equal to sin pi by cos pi. Cos pi is minus 1, sin pi is 0, so it's going to be minus 0 kind of thing. And if it comes to cot is going to become minus infinity. So the graph is going to become, at pi it is minus infinity. Again the same thing is going to repeat over here. Again the same thing is going to repeat over here. Yeah, so the graph is going to repeat here. So if you see carefully, the domain is going to become all real numbers minus set n pi, where n belongs to integers, and range is going to become, I think all real numbers come under the range, and then period is going to become the same as the tan period, that is pi. I think friends, this is what about the graphs. I think I could not say anything more than that. So yeah, that's it about the cot, cosecant and secant, and sine, cos and tan. So if we know this graph, it is like the ocean of knowledge. If one graph you know, you can create a ocean of knowledge. So thank you very much. If you like my video, please like it, please share it, please subscribe for it, and if any doubts, please contact at spacetutorials@gmail.com. Thank you.